All right, everybody. Welcome back to class. I'll try and keep this short and sweet for you guys. Obviously, I got to warm up for you. So we're going to write the Pythagorean theorem. Now, hopefully you guys know this by now. If not, look at my wall. It has it on there. I'm not trying to hide it from you. Hopefully you guys know Pythagorean theorem is a squared plus b squared equals c squared, seeing as you guys used that all the time last semester when we were working with trig. Today, what we're going to do, we're going to talk about the midpoint and distance formulas. And so kind of here's the situation we got. Triangle has vertices at 2, 3, 3, -2, and -5, -1. We want to know, is it an isosceles triangle? Okay? You guys remember back to your geometry days, isosceles triangle means that two of the sides are the same length. So, in particular, your book's being nice to you here, is it true that AC is equal to BC? So, are these two sides right here the same length? Well, what is needed to answer the question is a formula that gives the distance between 2 points in terms of their coordinates. Well, what we can do is we can go to our distance formula, okay? But really, what we're doing is if I look at AC, I can really make a triangle here. Okay, going through, ooh, that's kind of bad, but we're dealing with my ability to draw. Okay, what we're doing is we're finding how long each of those sides are with AC being our C value. So, if I go back to my Pythagorean theorem, I know that a squared plus b squared is equal to c squared, but I don't want c squared. I just want c. So I take the square root of both sides. And a squared plus b squared cannot be broken down any more than that, okay? It just has to stay the square root of a squared plus b squared. So now all we got to do is figure out how long these sides are. Well, I can go AC is equal to the square root of, and I'm going to call this side here A and this side here B. Okay? To figure out how long A is, all I have to do is look at my x values and subtract them. I can go -5 minus 2 and square it, because we're still working with a squared, okay? Plus my side B. Now, I'm seeing how far up and down I've gone. Well, now I just subtract my y values. So I'm going to go -1 minus 3, and I'm going to square it. Again, still working with b squared. So I get that AC is really equal to the square root of -7 squared plus -4 squared. Or to simplify this down a little bit more, I'm going to go the square root of 49 plus 16, or the square root of 65. Now, just for sake of our argument, to see if these are the same lengths, I'm just going to leave this as square root of 65 for right now. I'm not even going to try and break it down. I don't think any perfect squares go into square root of 65 off the top of my head, but I could be mistaken. So, now, we're going to see if this works on side BC now as well. So, BC, okay, I got to find the lengths of my sides, so all I got to do is subtract my x values. And in this case, I'm going to go 3 minus a -5. Minus -5. And I'm going to square that. And I'm going to add on the subtraction of my y values. So I'm going to go -2 minus -1. -2 minus a -1. And I'm going to square that. And of course, take the square root of that whole thing. So I'm going to get the square root of, now, since I'm subtracting negatives, I can add a positive. I'm going to get 8 squared plus, again, subtracting a negative, I can add a positive. And I'm going to get 1 squared, also known as the square root of 64 plus 1, or square root of 65. So that was, looks like these two are the same length, therefore it's going to be an isosceles triangle. Now, the reason I tie the Pythagorean theorem into all of this, just like I showed you, you could do a squared plus b squared equals c squared, and you can actually turn a triangle just to find your side lengths here. You count your spaces here and get that this is 8 and this has a length of 1, and 8 squared plus 1 squared would get you 65, and then take the square root of that with this side that we're looking for being that hypotenuse of our right triangle. So, highlighted today, distance formula right here, just what I showed you, okay? Subtract your x values, square it, add on your y values that are subtracted and squared, and that will give you the distance between any 2 points on the coordinate plane. Midpoint formula. This is very simple. If something's in the middle, okay, you think finding the middle of 2 numbers, you find the average of those 2 numbers. You add them together, divide by 2. All you're doing is finding 2 averages here. Add your 2 x values together, divide by 2. Add your 2 y values together, divide by 2. So let's take a look here at your midpoint. Actually, before I do that, honestly, I don't care if you memorize the distance formula or you use Pythagorean theorem. The distance formula is derived from the Pythagorean theorem. If you guys want me to show you how that works, that is, I can absolutely do that when I get back. But just so that this is a little shorter, a little less boring for you guys, I'm going to try and keep the video moving here, and we can talk about that if you guys want when I'm back. So if we're going to find the midpoint M of segment PQ that has endpoints of -1, 3 and 2, -7, all we need to do is plug into our midpoint formula. Okay? Remember, x sub 1 plus x sub 2 divided by 2, and this is an ordered pair. So this is a comma, and then I'm going to go y sub 1 plus y sub 2 divided by 2. Okay, it doesn't matter which one you call x sub 1, x sub 2, really. Just keep them the same. So I'm going to take -1 plus a -2, divide it by 2, and I'm going to take 3 plus a -7, divide it by 2, and call it good. -1 plus -2 is going to give me a -3 over 2, and I don't know how that got changed to an addition sign. It should be a comma. -3 plus -7 is -4 divided by 2. As always, if it divides out evenly, great, you can divide that out. If not, you can leave it as fractions. Remember, fractions are friends. So I'm going to get -3 halves, and -4 divided by 2 is going to give me a -2. That is going to be the midpoint of those 2 points. So halfway in between there. This one is a little different, but I'm going to be honest, these are really fun problems, in my opinion. So one endpoint of PQ, which is our segment that we're looking for, is point P at 3, 1. And I tell you that the midpoint is 1, 5. We need to find what point Q is. So I give you the midpoint, I give you one of the endpoints, but I don't tell you what the other one is. Okay? Again, I give you a midpoint. We need to use our midpoint formula. X sub 1 plus x sub 2 divided by 2 y sub 1 plus y sub 2 divided by 2 is how we find a midpoint. So I have some q at x sub 2, y sub 2. So to find that midpoint, okay, I would add, I'm going to let my 3 be my x sub 1, and y sub 1 will be my y, or 1 will be y sub 1. So I plug into my formula. So I'm going to take 3 plus the unknown x value that I'm looking for divided by 2. Now, I'm not actually going to use the whole formula, okay? This piece, 3 plus x sub 2 divided by 2, that is how I find the x value of my midpoint, okay? This is going to be my x value, 1. That's how I find it, so I'm going to set it equal to whatever the midpoint x value is, in this case, 1. I'm going to set up a very similar equation to help me find my y's. Y sub 1 is going to be 1 plus y sub 2 that comes from q. I don't know what it is. Y sub 2 divided by 2. That has to be equal to the y value of my midpoint, this 5. Okay? This 5 is going down here. Now I have two small equations that I can solve. Okay, since the whole equation is getting divided by 2, I'm going to multiply both sides by 2 so I can get to that variable that I want. Okay, so I'm left with 3 plus x sub 2 is equal to 2. Subtract 3, I get that x sub 2 is equal to negative 1. And a very similar process for my y's. Multiply by 2. I get that 1 plus y sub 2 is equal to 10. Subtract 1. Y sub 2 is equal to 9. So point Q is at the point negative 1, 9. And there's your homework. We'll check this when I get back. If you have questions, let me know. I'll be happy to answer those. As always, you can ask each other questions, help each other out. Otherwise, shoot me an email. I'll do my best to try and keep up on those. But obviously, since I'm not here, I will be doing other things. Thanks for watching. I will see you guys when I get back.